Hi, I'm Rob. Welcome to Math Antics. In our last algebra video, we learned that algebra involves equations that have variables or unknown values in them. And we learned that solving an equation means figuring out what those unknown values are. In this video, we're going to learn how to solve some very simple algebraic equations that just involve addition and subtraction. Then in the next video, we'll learn how to solve some simple equations involving multiplication and division. Are you ready? I thought so. Okay, so if you've got an equation that has an unknown value in it, then the key strategy for solving it is to rearrange the equation until you have the unknown value all by itself on one side of the equal sign and all of the known numbers on the other side of the equal sign. And then you'll know just what the unknown value is. But how do we do that? How do we rearrange equations? Well, we know that algebra still uses the four main arithmetic operations: addition, subtraction, multiplication, and division. And we can use those operations to rearrange equations, as long as we understand one really important thing first. We need to understand that an equation is like a balance scale. You've seen a balance scale, right? If there's the same amount of weight on each side of the scale, then the two sides are in balance. But if we add some weight to just one side, then the scale will tip. The two sides are no longer in balance. An equation is like that. Whatever is on one side of the equal sign must have exactly the same value as whatever's on the other side. Otherwise, the equation would not be true. Of course, that doesn't mean that the two sides have to look the same. For example, in the equation 1 plus 1 equals 2, 1 plus 1 doesn't look like the number 2, but we know that 1 plus 1 has the same value as 2. So 1 plus 1 equals 2 is in balance. It's a true equation. The reason we need to know that equations must be balanced is because when we start rearranging them, if we're not careful, we might do something that would change one side more than the other. That would make the equation get out of balance and it wouldn't be true anymore. And if that happens, we won't get the right answer when we solve it. Oops. That sounds pretty bad, huh? So how do we avoid that? How do we avoid getting an equation out of balance? The key is that whenever we make a change to an equation, we have to make the exact same change on both sides. That's so important, I'll say it again. Whenever we do something to an equation, we have to do the same thing to both sides. For example, if we want to add something to one side of an equation, we have to add that same thing to the other side. And if we want to subtract something from one side of an equation, then we have to subtract that same thing from the other side. And that's the same for multiplication and division. If we want to multiply one side of an equation by a number, then we need to multiply the other side by that same number. Or if we want to divide one side of an equation by a number, then we have to divide the other side by that number also. As long as you always do the same thing to both sides of an equation, it will stay in balance, and your equation will still be true. Alright, like I said, in this video, we're just going to focus on equations involving addition and subtraction. And here's our first example. X plus 7 equals 15. To solve for the unknown value x, we need to rearrange the equation so that the x is all by itself on one side of the equal sign. But what can we do to get x all by itself? Well, right now, x is not by itself because 7 is being added to it. Is there a way for us to get rid of that 7? Yes. Since 7 is being added to the x, we can undo that by subtracting 7 from that side of the equation. Subtracting 7 would leave x all by itself because x plus 7 minus 7 is just x. The plus 7 and the minus 7 cancel each other out. Okay, great. So we just subtract 7 from this side of the equation and x is all by itself. Equation solved, right? Wrong. If we just subtract 7 from one side of the equation and not the other side, then our equation won't be in balance anymore. To keep our equation in balance, we also need to subtract 7 from the other side of the equation. But on that side, we just have the number 15. So we need to subtract 7 from that 15. And since 15 minus 7 equals 8, that side of the equation will just become 8. There. By subtracting 7 from both sides, we've changed the original equation x plus 7 equals 15 into the new and much simpler equation x equals 8, which tells us that the unknown number is 8, and we've solved the equation. And to check our answer, to make sure we got it right, we can see what would happen if we replace the unknown value in our original equation with the number 8. Instead of x plus 7 equals 15, we'd write 8 plus 7 equals 15. And if that's true, then we know we got the right answer. Pretty cool, huh? Let's try another one. 40 equals 25 plus x. This time, the unknown value is on the right-hand side of the equation. Does that make it harder? Nope, we use the exact same strategy. We want to get x by itself, but this time x is being added to 25. But thanks to the commutative property, that's the same as 25 being added to x. So to isolate x, we should subtract 25 from that side of the equation. But then we also need to subtract 25 from the other side to keep things in balance. On the right side, x plus 25 minus 25 is just x. The minus 25 cancels out the positive 25 that was there. And on the other side, we have 40 minus 25, which would leave 15. So the equation has become 15 equals x, which is the same as x equals 15. Again, we've solved the equation. So, whenever something is being added to an unknown, we can undo that and get the unknown all by itself by subtracting that same something from both sides of the equation. But what about when something is being subtracted from an unknown? Like in this example, x minus 5 equals 16. In this case, x is not by itself because 5 is being subtracted or taken away from it. Any ideas about how we could get rid of or undo that minus 5? Yep, to undo that subtraction, this time we need to add 5 to both sides of the equation. The minus 5 and the plus 5 cancel each other out and leave x all by itself on this side. And on the other side, we have 16 plus 5, which is 21. So in this equation, x equals 21. Let's try another example like that. 10 equals x minus 32. Again, the x is not by itself because 32 is being subtracted from it. So to cancel that minus 32 out, we can just add 32 to both sides of the equation. On the right side, the minus 32 and the plus 32 cancel out, leaving just x. And on the left side, we have 10 plus 32, which is 42. Now we know that x equals 42. Okay, so now you know how to solve very simple equations like these, where something is being added to an unknown or something's being subtracted from an unknown. But before you try practicing on your own, I want to show you a tricky variation of the subtraction problem that confuses a lot of students. Do you remember how subtraction does not have the commutative property? If you switch the order of a subtraction, it's a different problem. Suppose we get a problem where instead of a number being taken away from an unknown is being taken away from a number. What do we do in that case? Well, we still want to get the unknown all by itself, but it's a little harder to see how to do that. In this problem, 12 minus x equals 5. The 12 on this side is a positive 12, so we could subtract 12 from both sides. That would get rid of the 12, but the problem is that wouldn't get rid of the minus sign. That's because the minus sign really belongs to the x, since it's the x that's being subtracted. Subtracting 12 would leave us with negative x on this side of the equal sign, which is not wrong, but it might be confusing if you don't know how to work with negative numbers yet. Fortunately, there's another way to do this kind of problem that will avoid getting a negative unknown. Instead of subtracting 12 from both sides, what would happen if we added x to both sides? Can we do that? Can we add an unknown to both sides? Well, sure, why not? We can add or subtract anything we want as long as we do it to both sides. And when we do that, the minus x and the plus x will cancel each other out on this side, and on the other side, we get 5 plus x. Now our equation is 12 equals 5 plus x. And you might be thinking, but why would we do that? That didn't even solve our equation. Ah, that's true. But it changed it into an equation that we already know how to solve. Now it's easy to see that we can isolate the unknown just by subtracting 5 from both sides of the equation. And that will give us 7 equals x, or x equals 7. It just took us one extra step to rearrange the equation, but then it was easy to solve. Okay, that's the basics of solving simple algebraic equations that involve addition and subtraction. You just need to get the unknown value all by itself, and you can do that by adding or subtracting something from both sides of the equation. And this process works the same even if the numbers in the equation are decimals or fractions. And it also works the same no matter what symbol you're using for an unknown. It could be x, y, z, or a, b, c. The letter being used doesn't matter. Remember, when it comes to math, it's really important to practice what you've learned. So be sure to try solving some basic equations on your own. As always, thanks for watching Math Antics, and I'll see you next time. Learn more at mathantics.com.